Hello everyone and welcome to today's low-level design session. Today we are diving into one of the most relatable and exciting systems you interact with almost every day, a food delivery system. Throughout this case study, we will explore how to take a real-world problem, break it down into manageable pieces, and build a solid, extensible, and maintainable design. So let's jump right in. Before we begin building, it's important to be clear about what we are trying to achieve. Our goal today is to design a food delivery system, keeping in mind not just the features but also the overall quality of design, things like modularity, scalability, and clarity. We will model the key entities, design the service layers, introduce some design patterns where needed, and also think about how the system will evolve over time. This exercise will help you practice how real-world LLD is done beyond coding, but by focusing on design thinking. Let's frame the problem first. We want customers to be able to browse a variety of restaurants, explore menus, place orders, and track deliveries in real time. At the same time, delivery partners should be able to receive delivery assignments, update order statuses, and complete deliveries. Restaurants will manage their menus and accept orders. Administrations oversee the ecosystem, handling issues, compliments, and reports. Thus, we have four key actors: customers, restaurants, delivery partners, and admins. This initial framing is important. If you miss actors early, the design will suffer later. Now, let's look at the features we must absolutely support. The system should allow multiple restaurants and multiple delivery partners to coexist. Customers must be able to track their orders at every stage, from being prepared to being delivered. They should also be able to rate and review their experience. Offers, discounts, and promotions should be supported in the ordering flow. However, some areas are deliberately kept out of today's scope. For instance, we won't cover the onboarding of new restaurants, complex AI-based recommendation engines, or full payment gateway integrations. This sharp focus keeps our design crisp and achievable within the given time frame. Now comes the fun part, identifying core entities. The foundation of any system is the data it manages. In our case, at the center, we have a user entity representing both customers and delivery partners because they share many common properties like name, phone number, and login details. Restaurants are another major entity having menus, addresses, and business details. Each menu item belongs to a restaurant. Orders are the heartbeat of the system. They link customers, restaurants, delivery partners, and payments together. Payments and reviews are also first-class entities because they represent critical actions customers take after receiving service. Next, we dive deep into the attributes of these entities. For users, typical fields like user ID, name, phone number, and role are obvious. Customers may also maintain multiple delivery addresses and order histories. Restaurants have a menu that lists their offerings, each menu item having its own name, description, price, and availability status. Orders include fields such as order ID, customer ID, restaurant ID, list of items, price details, current order status, timestamps, and the assigned delivery partner. Payments will have payment IDs, methods, amounts, and statuses like paid or failed. Lastly, reviews include a rating value, a textual comment, and references to both the customer and the restaurant. Each entity is crafted to ensure clarity, extensibility, and correctness. Visualizing the system helps solidify our understanding. Here's a simplified view of our class diagram. You can see that customer and delivery partner are specialized versions of user. An order links to multiple menu items and connects to a payment entity. The association lines between classes such as has a and uses help us visualize how the components interact. Remember, diagrams are not just documentation, they are thinking tools that reveal gaps or redundancies in our design early. Moving on, a good system separates what is done from how it is done. That's where the service layer comes in. Each service will manage a particular domain. Restaurant service manages the discovery of restaurants and their menus. Order service handles placing, updating, and cancelling orders. Delivery service tracks the delivery lifecycle and assigns partners dynamically. Payment service manages financial transactions securely and reliably. Review service captures feedback and helps maintain platform quality. By keeping services focused and cohesive, we make the system much easier to maintain and evolve. Breaking it down further, restaurant service exposes APIs to fetch restaurant listings and menus. Order service provides endpoints to place a new order, cancel an order, and view order status. Delivery service assigns available delivery partners based on proximity or load balancing algorithms. Payment service integrates with payment providers to process transactions, handle retries, and deal with failures. Review service collects and aggregates user feedback to help restaurants improve. By splitting these responsibilities cleanly, we not only prevent code bloat but also promote faster parallel development. Good designs often leverage well-known patterns. In our system, we will use the singleton pattern to ensure services like payment services or order service have only one instance managing shared resources. The factory pattern will help us instantiate different types of users, customers, delivery partner, admin based on context. The observer pattern is perfect for sending real-time order status updates to customers without tightly coupling notification logic into the core services. The strategy pattern lets us plug different delivery assignment algorithms easily. For example, nearest driver first, load balanced, or highest rated driver first. Design patterns act as tested, proven solutions to common problems, giving us flexibility without reinventing the wheel. Now let's simulate how a customer would place an order. First, the customer browses menus through the restaurant service. Once they choose their items, they initiate an order, which is managed by the order service. The system then notifies the restaurant, which either accepts or declines the order. If accepted, the delivery service finds a delivery partner and assigns them to the order. The delivery partner picks up the order and updates statuses like picked up or and out for delivery. Meanwhile, the customer can track every step. Once delivered, the payment service finalizes the transaction and the review service encourages the customer to leave feedback. Each handoff between modules is clear, smooth, and designed to minimize confusion and delay. No real-world system is complete without handling errors gracefully. What if a restaurant rejects the order after acceptance? What if a delivery partner cancels midway? What if a payment fails? We need to build fallbacks. On restaurant rejection, notify the customer and offer alternatives. On delivery partner dropout, immediately reassign another nearby partner. On payment failure, hold the order temporarily and allow payment retry. Designing for failure resilience is as important as designing for success, especially in customer-facing systems where reliability builds trust. Now it's your turn. Your homework is to build the basic class structures for this system. Define the classes for user, customer, delivery partner, restaurant, menu item, order, payment, and review. Implement basic service classes like order service and delivery service. Simulate a user browsing restaurants, placing an order, assigning a delivery partner, and completing a payment. Focus on correct class relationships, clean method signatures, and using appropriate design patterns where applicable. To wrap up today, we learned how to approach a real-world system design with a clear mindset. We emphasized breaking down complexity, modeling core entities, designing clean services, applying the right patterns, and planning for edge cases. The journey from requirements to architecture is where most of the real thinking happens in software engineering. With practice, you will become comfortable not just writing code, but designing systems that are resilient, extensible, and a joy to work with. Thank you for your attention and happy designing.